A super happy fun ball. I like that. I like whoever, whatever professor contributed this question. I like his sense of humor. A super happy fun ball is dropped from a height of 5 feet and rebounds 8/9 of the distance from which it fell. How far will the ball travel before it comes to rest on the ground? It will travel blank feet before it comes to rest on the ground. What are they talking about? Well, let me draw this out. Put the ground in here. And so I've got this super happy fun ball. And they're going to, well, that's a terrible ball, isn't it? There we go, use a little tool there. And so this ball is going to drop down and it's going to bounce. And they're saying it's 5 feet. It's dropped from a height of 5 feet. So this is 5 feet. And then it's going to bounce back up. But it doesn't bounce all the way up, right? It only bounces 8/9 of the way up, right? You can never bounce all the way up because of what physics calls it conservation of energy. There's always a little bit of loss of energy when the ball bounces, and so it can't come all the way back to its original height. So it'll bounce up. Now it's not gonna really go sideways, but I just want to show it. It's gonna be, say here, although it looks like it got bigger too. Let's do the best I can. There we go. Now it got smaller. Now I'm getting too picky probably. There we go. Looks a little smaller still. One more time. All right. So it bounces up. Now, how far does it bounce up? Well, it bounces up 8/9 times 5, whatever that is, right? 8/9 of the way, 8/9 of the 5-foot height, right? So it travels down. It travels down. Let me use a different color for clarity. It travels down 5 feet, up 8/9 times 5, and then of course it travels back down again, whatever 8/9 times 5 is. You get an idea here? Extend this. Now it's not really going sideways, but it's going straight up and down, but I'm just doing this so we can see it. So, right, so the ball goes up and then back down, and it hits the ground here. Let me draw the ball hitting the ground. Well, I'm just going to draw it up. So then it bounces up again. Right? This time it's going to bounce up not quite as far. It's going to bounce up, let's say, right there, which is what? That's 8/9 of how far it bounced up before. So that's going to be 8. Whoops. Change my thing here. That's going to come up. That's going to come up. 8/9 of 8/9 of 5. You see where I'm coming up with that? Because last time it traveled 8/9 5, right? It went down 5, and then it went up 8/9 of 8/9 times 8/9 of the distance from which it fell, right? It fell 5 feet, and went up 8/9 of 5 feet, and then back down 8/9 of 5 feet. Then it's going to go up 8/9 of 8/9 of 5 feet, right? Because it just fell 8/9 of 5 feet, so it's going to go up 8/9 of 8/9 of 5 feet, and then back down again that same distance, because however far it goes up, it's got to come back down 8/9 of 8/9 of 5 feet again, right? Etc. So this ball is going to go up and down, up and down, up and down, up and down, up and down forever. You tracking with me? Well, not forever. It'll eventually comes to rest on the ground. So and the question is, how far will the ball travel before it comes to rest on the ground? They mean up and down. The ball's not going sideways. I should add some words in here. Travel up and down. They mean how far will the ball travel up and down, up and down, up and down before it's not going sideways. I'm just showing it sideways so we can see it. So the ball's going up and down, up and down, up and down. Well, how far is it going to travel? Well, it 5 feet plus 8/9, if then it went up 8/9 of 5 and down. So it traveled 8/9 of 5, 8/9 of 5. In fact, you could say, let's just do it this way. It traveled 2 times 8/9 of 5. Is that good? Because it went up 8/9 of 5 and down 8/9 of 5. So 2 8/9 of 5 plus, and then it'll do this, right? 2 8/9 of 8/9 of 5 plus, etc. forever. It's infinite. Why is it infinite? Well, because they're saying eventually it's going to come to rest on the ground. So that ball will just bounce up less and less and less and less and less, and infinite bounces until eventually it settles on the ground. So they're asking me to add up all. Why? How did I know I was supposed to add them all up? Well, they want to know the total amount of up and down travel. Up and down travel. So you got to add up all the ups and the downs and the ups and the downs, and the ball bounces up and down forever and eventually comes to rest on the ground. So that's what we got to add up. So what kind of series is that? That's geometric, because every time you multiply, well, here, let's do this. It's it's geometric after the first 5. From here on, wait, is that right? Yeah, sorry, I'm not being very clear. Yeah. So that is right. Okay, sorry, I'm thinking it over here. All of this is geometric. Not the 5. The 5 is just going to be extra. Why? Because, look at it. From here to here, what happens? It multiplies by what? 8/9. Do you see it? Because this has 2 8/9 and 5. This is 2 8/9 of 5 and an extra 8/9. Every time it's just going to keep multiplying by an extra 8/9. Do you see that? And you might think, well, that doesn't work from here. Right. That's why I put the 5 outside of the picture, because that doesn't really work for that first step, because it doesn't just multiply by 8/9 on that first step. It multiplies by 2 and also 8/9. And I want to make them all the same. I hope this is making sense. So it's basically going to be 5 plus an infinite geometric series with my R number being 8/9 and my A1, my first term, being 2 times 8/9 times 5. That makes sense. I'm calling this the first term, A1. This is A2. What about the 5? He's extra. Why did I set him out extra? Because he doesn't fit the pattern. Not exactly. The rest of them fit the pattern. I hope this isn't too confusing for you. So again, the 5 is separate. He doesn't exactly fit the pattern. So I'm calling this A1. This is like the first term. Here's the pattern. This is right here, the infinite. Well, I shouldn't put it there. The infinite geometric series is there. Are we good there? Am I making sense? And so it's going to be 5 plus, what's the formula for an infinite geometric series? If you come on down to the notes, here it is right here. It's A1 over 1 minus R. So it's going to be A1 over 1 minus R. All the infinite geometric series will be A1 over 1 minus R, and you get the 5 in the front. The R is 8/9. By the way, the R has to be between -1 and +1. I don't know if you notice that in the notes. Here's 0. The R, the 8/9, is about right there. 8/9. So it works. So it's yes. The R is between -1 and +1, so we can use the formula. So it's yes. That means it's okay to use the A1 over 1 minus R formula. So let's do it. So it's 5 plus, what's A1? It's this. It's 2 times 8/9 times 5 over 1 minus R. What's R? 8/9. So there it is. That's a bit messy, isn't it? And so you could just type that all into your calculator if you want. That's fine. If you want to just crank that in the calculator. I'm going to do a couple by hand steps. I'm going to go, look, it's 2 times 8, and scribble it here. On the bottom, 1 minus 8/9 Yeah, 1 is 9/9, right? 9/9 minus 8/9. This is 1/9 on the bottom, isn't it? So you can do that in your calculator if you want. Again, I'm gonna do it by hand. The top is the 2 is 2 over 1, 8 over 9, 5 over, right? When whole numbers interact with fractions, all over 1/9. So that's 5 plus, and that's, so they multiply, don't they? That's going to be 80 over 9 all over 1/9. Did you track me through there? I did 2 times 8 times 5 and 1 times 9 times 1. And then grab this 1/9 and flip it up. The 5 is just waiting out there in the front. It's 80 over 9 times 9 over 1, right? Dividing is upside down, multiplying cancels. 5 plus 80, 85. So that ball, that super happy fun ball, will bounce up and down, up and down, up and down, a total distance of 85 feet before it finally comes to rest on the ground. That was an interesting question, wasn't it? So again, the ball went down 5, and then it bounced up 8/9, 8/9 of 5, and then back down 8/9 of 5. It's got to fall from whatever height it was. And then it went up 8/9 of 8/9 of 5 and down, same thing. So it came, so it's 2 8/9 of, so we have the 5 in the front, and then 2 8/9 of 5, and 2 8/9 of 8/9 of 5, etc. So we just grab this stuff and let the 5 sit separate because this stuff fits the geometric pattern, multiplying by 8/9 every time. Then we said that's my R. It fits between -1 and +1, so we can use the formula. So we use the formula A1 over 1 minus R, and we still have the 5 in the front. Figure that all out. 85 feet total distance. There we go.